Hello everyone, let's study the basics of uniform circular motion. When we say uniform, it means the speed is constant. And if it is circular, this object moves along a circular path. Example for this uniform circular motion is a stone tied to a string and whirled horizontally at constant speed. And then take note, in our uniform circular motion, although the magnitude of the speed is constant, but the direction is changing. So what do you mean by that? If direction is changing, then this refers to a velocity which is also changing. Then if the velocity is changing, it also refers to an accelerated motion. Again, if the direction is changing, the velocity is changing. If there is a change in velocity, then the motion is accelerated. So therefore, A is not 0. Therefore, the uniform circular motion is an accelerated motion. So if this is accelerated, then there is an unbalanced force. So if there is an unbalanced force, according to the second law of Newton, then our equation for this force is equal to ma. And since acceleration and F net must be in the same direction, then what must be the direction of this acceleration or this force? So try to consider our example. A stone tied to a string and then whirled horizontally. So for this position, let's label as V1 or the speed of the stone tangent to the circular path at this position. And after some time, after delta t, the stone will be moved in here, in this position. And let's label the velocity of the stone as V2 at this instant. And the radius, let's label as R, R1 for V1, R2 for V2. But then take note that since it is circular, our R1 is just equal to R2 in magnitude. And also our V1 is also equal to V2 in magnitude. Why? Because in here it's circular. And for this, magnitude of the speed, because we have a constant speed. And in this illustration, we can conclude that since our velocity is always tangent to our circular path, then the angle between our radius and our speed at an instant is always perpendicular at any point along the circular path. Following the direction of V1, similar in this direction at this angle, and then the V2 in here. By law of adding vectors, if V1 plus the V2, this is our resultant vector R, or the VR. But if we change the direction of our V1, sample opposite, this is now the direction. Take note the arrow pointing in opposite direction. So if V2 plus the negative of V1, so in this direction, therefore this is V2 minus V1, and this is not anymore the resultant vector, but the change in its velocity, or V2 minus V1. The angle formed by these two vectors, V1 and V2, is also equal to the angle formed between R1 and R2. Thus, the two triangles formed are similar. Since the two are similar, they can have proportional sides. So with the vertex angle theta, they have equal angle theta. Then, since the two triangles are similar, so we can write in proportion that delta V over V is equal to delta R over R. Then multiplying both sides with this time, the time elapsed between point 1 or position 1 to position 2, we can have these equations that delta V over delta T is equal to V over R, then we have delta R over delta T. But if we take a limit the time. We'll move the two positions, point 1, point 2, very close to each other. So we'll limit our delta t to approach 0. So this term becomes, this is also equal to, so this refers to the instantaneous acceleration, this side. So this is the acceleration. If delta t approaches 0, our delta r, based on our figure, our delta r will be equal to x, which is the actual length or path taken by the particle or the arc length. It will not anymore look like an arc, but it will be like a straight line, or we can equate this as x if our delta t approaches 0, meaning the 2 points now are very close to each other. So our equation becomes the delta r, if delta t approaches 0, our delta r also will be equal to Rx or delta x. This term, the delta x over delta t, is also equal to v, or simply v, instantaneous speed, or simply equal to v squared over r. This is now our equation for acceleration. But what acceleration is this? This acceleration is pointing towards the center. As we can see, the delta v now points towards the center of the circular path. So this change in velocity, which is the acceleration, is also towards the center. This is now our centripetal acceleration magnitude, which is equal to v squared over r. And if this is our centripetal acceleration, what is our centripetal force? Our centripetal force is equal to, according to the equation of second law, that is equal to ma, but our acceleration refers to the centripetal acceleration. Therefore, Fc, or centripetal force, is equal to mv squared over r. So in this illustration, the unbalanced force is caused by the tension on the string, which pulled the stone towards the center. We call this as the centripetal. We can also label the F net, in this case, as Fc, or the centripetal force, and AC as centripetal acceleration. Since we cannot use the kinematic equations to solve for acceleration, since the magnitude of velocity is constant, if we use the linear equations as a kinematic equations, automatically the acceleration or the change in velocity is always equal to 0. So we have this equation now. The centripetal acceleration is equal to v squared over r, and our centripetal force, which is the net force causing the stone to change its direction, is equal to mv squared over r. And take note that for our uniform motion, we can easily find the total distance traveled by a particle. How? Review that v is just equal to total distance over total time elapsed. But in our uniform circular motion, the total distance is just the circumference of the circle, and the total time is just the period. So by definition, what is a period? Period in symbol t is just equal to the time for one complete cycle or one complete revolution. And period is the reciprocal of frequency in symbol f. For frequency is defined as the number of revolutions per unit time. Therefore, the relationship between frequency and period is just this one, this equation. So our v, therefore, in a uniform circular motion, what's the circumference? Simply the 2 pi r. The r is the radius of our circle and the period t. Or we can have this in terms of frequency 2 pi RF. Therefore, rewriting our equation AC, this is equal to 2 pi RF, then square over R, or simply 4 pi square RF square. Therefore, you can solve the centripetal acceleration if you are given radius and frequency, or you can use period. And also, in that way, having only radius and period, you can solve for the centripetal force.